Here we're dealing with real data, so we need to be a little bit careful and to plan carefully before we start coding. Let's see what the first few lines of this chick.fasta file look like. Here they are, and if you have downloaded a new version of the file, the contents may be a bit different, but they will be organized in the same way. As you see, chicken proteins are listed here in FASTA format, one after the other. That is to say, there is a header, and that would be this line, or that one for the second protein, or the third one down here. And the headers always start with a greater than sign, followed by accession codes of the proteins, and then the description, and then the name of the organism, which is Gallus gallus, and then some other information. And then after the header line there is the protein sequence proper, and that is essentially a string of uppercase characters, and here it is. Now there is no particular meaning in the new lines, so the new lines are just to keep the text tidy and wrapped, but they are clearly not part of the protein itself. So clearly, before we scan one of these sequences to see if it matches our PROSITE pattern, we've got to get rid of these new lines. A third consideration is that this file is long, so it lists about 16,000 proteins, so we want to process them one at a time, and we want to avoid having to load all of this file into memory at once. The way we are going to deal with this data is as follows. We start reading the file, and the first thing we encounter is a line beginning with a greater than sign, so we know that's a header, and we will remember it as the name of the current protein that we're processing. After that comes the sequence, so we'll read that one line after the other, and we'll use a string accumulator if you want. That is a string variable to which we will add each line as we read it, removing the new line character. So eventually we will find a new greater than sign. That is, to us, the sign that the protein we were reading is finished, we have all of it, and we're moving on to another protein. So before we do that, we are going to try to match our regular expression against the sequence. If it does match, it means that this protein is part of the thyroidoxin family, so we're going to print the header that we had kept in store. And if it doesn't match, then we just discard this protein, and in any case we're ready to move on to the next. And we'll carry on doing that until the end of the file.